A yellow class, Thursday, January the 12th. Yeah, January 12th, somebody's birthday. Happy birthday. I'm somewhere, somebody's birthday. In any case, here's the deal. Next to this problem that we're going to call real world, the way to notice a real world problem is they try and describe something that's real, something that happened in real life. And for our purposes, that changes the domain, and that makes us have to do something special with our table. And here comes the thing it makes you do. Where I'm going to write real world. I'm going to write real world right here. I'm going to ask you to do the same. Why would it be real world like a football is kicked? Okay, that's in real life. Whenever we're going to use math, like right now. Right now, when you kick this football is when you're going to use it. Actually not. You have to do a math problem with it. And I should say this to you just in case a math teacher has never admitted it to you. I'm okay with it, because technically I'm fake math. I can do it, but I don't love it. Some people love it. I think Tim, I could be wrong, but Tim the tutor, I think he loves math. Yeah, I think he likes it. Me, it gives me $78,000. Yeah, I can buy whatever candy I want. If I want Snickers, I'll buy Snickers or whatever. So what I was gonna say is this. Lost my train of thought. I went to that Snicker thing. I don't know what I was about to say. 45, I'm losing my mind. But like one day I just walked like, who are you all? Where am I? What is it? All right, real world. Kick a football. Oh, math that I'm teaching you, you will not use in real life. So you never have to ask, when are we going to use it in real life? The answer is never. Yeah. At the market, do I use it? No, I give them this little card. They slide it, and they give me stuff back. I go to McDonald's, I give them a card. They slide it, and they give me stuff back. I get in my car, I twist the key, it turns on. Yeah, you don't use it. Now, a few of you might become a scientist, or you go into the world of computers. Yes, you will need it for what? I don't know, because I've never used it. Now, the only reason I get to use it, again, like I said, is to make a little bit of money. So, don't let that mess with you. Just think of it this way. This is the price I have to pay to get out of high school. They give me a diploma that allows me to be able to work to get a little cash. If I do a little more school, I get a little bit more cash. And so for now, just think of it that way. It's just something we all go through, and then we all can hate it a little bit together. Not all. Some people actually like math, but real world. What I want to know: when you make your table, which you're about to, the domain, the axis, will always start with the number 0. So real world, you won't put negative numbers for your domain. You start 0, 2, 3, 4. 2, 3, 4. You can probably go on beyond that, but again, for real world problems, and they're going to be at least 1, 2, 3. At least 3 of them will be on your assessment. So be aware of that. Hopefully I wasn't recording that thing about not using math. I don't remember hitting pause. Whatever. All right, here goes. Do me a favor, please. Go to blue button table. Oh, shoot, I shouldn't have said that. Please go to your table and fill in the table for this problem. One of the two of you know how to get there, and hopefully between Nick and Marquise, you guys will help the other half of the table. One who's brand new, and the other one who may not be. Am I coming around to look at this one? You can ask someone around you. Blue button table. I like the idea of doing it with a 2, because again, if one doesn't know, the other one can't. Have them sit it down and have them punch into that thing so at least it gets in there. So take that out of the calculator, punch that in. So give them the calculator, and then have them punch it in that way. At least you guys get to have it. Or is it already in there? Oh, it's in there? Cool, cool, cool. Well, now I get the blue button table. There are 5 of them. Are there 5 tables? There are 5 tables. So get ready tables. Table 1, I'm going to ask for the range for the domain 0. Table 2, the domain for the range, the range for the domain 1, back table. I'm going to ask you for the range for the domain 2. I want you to feel range and domain, just other words for the x and the y. Right here, table 4, this table right here, the range for the domain 3. This table right up here, the domain for the range 4. Decide who's going to say it, I don't mind. Whole table, have backup. If I were in your seat, usually I wait, I hold out, let the person who's willing to speak up. All right, here we go. Let's see what we got here. Let's do it. 0, what's the range, please? Oh, knocked out. 1, what's the range? 14, I'll take it. Ooh, these numbers are going really fast. Back table, what's the range on 2? I'll come back to you. This table here, the range on the domain 3. 30. 4, right here, what's the range? 42? 32. Oh, these odd numbers. Table 2, straight back. 8. Oh, it feels a little bit weird. It feels like it's gonna grow. Is it not doing? Can we get some backup for back table? Someone help on. 24. We'll take it. And we have to find out kind of what happened there. All right. Am I gonna do anything other with this one? The main thing I want to do, so I can jump on to those 5 main problems I'm gonna try and get through, is this. One, on the assessment, if ever they give you an equation, we want to turn that equation into a table. We turn it into a table, we know if we need to make a graph, we can use our table for that. So equation gets you a calculator. For the most part, if it's an easy one, I might go like, not this time, but for the most part, I'd rather have that calculator part there. The situation, they happen to tell us here. Let me read what this one is. It says here, your football is kicking to the air and follows the path defined by h equals all of that stuff, where x is the time. Please underline that. Usually they have to tell you what the letters represent, where x is the time. If you have a highlighter, you can use a highlighter. Hey, how many tables doesn't have a highlighter? Oh, that table has 2. Send one of those buckets up to the front table, please. And h is the height in meters. H is the height. So technically x is the, see if we can get this here. X is time. Writing red on red, that's a bad idea. And then what was y? They say h. It's height. Normally this thing would be y. Remember when you entered it to your calculators, you didn't go h equals. Your calculator would only handle y equals. So you have to know when you do a y equals, the original problem may have used some other letters on that side, and you just have to switch it in your mind. But this is what the h is, the height. Height is a weird word. Look how it's spelled. Like I got a 6-year-old, he's trying to learn how to read. How's he gonna read that? H. Doesn't make any sense. And then there's height, right? There's height. Watch this. Scratch off the H. Height? No, you have 8. Isn't that how you spell 8? That's how you spell 8, right? Yeah. So I don't even know. I hate you. Yeah, it doesn't matter. All right, fine. Turns out you like words and things that are interesting. Now I can't get it back. All right. So let's do this before I run out of time. And they're like, yeah, hate. Height. All right. In any case, once you have this, what I want to say to you on this type of problem, usually I have to give you a parabola. How do I know it's a parabola? There's a little exponent 2. The minute you see an exponent 2, you know you have a parabola. Also, you can write it. I say parabola just so I can spell it right. Parabola. The other thing I should say in 30 seconds is if anyone has difficulty in math or in school in general, it initially is an issue of memory. In other words, if I had a son that has 2, I might send him there. My 9-year-old's having trouble in math. Really? Math? But he's just memorizing stuff. What I would say is this. If you went to the library, you had difficulty in math or any other subject. Let's say it's math. You wouldn't go to the math section of the library. For those who have never gone, they have books in there and stuff. You can Google it. All right. When you go in there, you would actually go to the memory section. There's a section that teaches you how to improve your memory. Now, some of you say, well, okay, well, why wouldn't I go to the math section if I'm having trouble in math? Why would I go to the memory section? Because the rule is this. If you have a good memory, generally you're good in school. Teachers ask you to memorize which one's domain and range. You're like, okay, X is domain, got it. Y is range, got it. Next time they say domain and range, you remember that. People with bad memories, teacher says X is domain, Y is range. Next time it comes up, she says find the domain. You're like, or you do the punch thing on your calculator, and you're like, oh shoot, X is that little button to the right of the green one, to the right of the green. Next time our teacher says, all right, punch that in, you have a bad memory. You're like, I know there's a blue button. But it's not that you're not smart, it's that your memory doesn't hold the stuff. So if you go to the memory section, one thing they'll tell you is, of course, different colors help with memory. Turning things into pictures. Like if you had to memorize names, the rule, I bought this program called Mega Memory. It was a long time ago. But in that program, it teaches you turn the name that you want to memorize into a crazy picture. Like, for example, this whole height-hate thing, for some of you, will stick in your memory, even though you didn't have to learn it. But it's kind of odd. That's kind of weird. I never noticed the height thing. If there's a name, let's say I'm trying to remember a name. Let's say I'm trying to remember, let's say Jalen. You have to kind of think, okay, what can I turn Jalen into? Like, what kind of picture is a Jalen? Jail, okay, jail in, he's in jail, jail, okay. Then when you see the person, this works. Whenever you go to a party or an occasion where you want to memorize names, yeah, it takes like a few seconds. I get it. You look at the person and something you notice about them, glasses, hat, eyebrows, whatever it is. So if I look at jail and whatever I notice, now that I see that jail, he's in jail, whatever, something is in jail, then I have to attach that thing to his face, but in a violent way is the best way, because if there's pain, you will remember it. If there's emotion, you'll remember it. Now, how you got emotion on domain and range, I don't know. But what I'm saying is this. I hit it across the face, so next time I see Jalen, let's say I see his eyebrows, I see the blood, because the jail cell went into that, and now it's stuck in there, and every time I see him, boom, it's Jalen. What am I trying to say to you? Yeah, I gave you one of the basic techniques of memorization, which is turn whatever you want to remember into a picture. And then turn, if you want to remember several things, into several pictures that you hook together called chaining. But for those who ever had trouble in math, and you just want to get better, a little bit better, again, the better you improve your memory, automatically, the better you are at math. And of course, my son's having an issue with timetables, which of course that's the bottom line. You got to get your timetables, then everything else kind of comes along. What do we have here? Domain, we got range, we got this. Oh, last thing I want to say before I leave this. The domain of a real world problem will always start with 0 and then go on higher. The 0, I want you to note, is the initial amount. Initial amount. This line here tells you where things begin, called the y-intercept. Whenever you hear the y-intercept, the thing I want you to think, it's not like, okay, is that where it hits the y? No, no, no. Whenever you hear y-intercept, I want you to think, oh, that's where things began. Okay. The y-intercept for all of you was most likely in a hospital somewhere. That was your y-intercept. This is where you began. So what's beginning right here? Let's see. They kick the ball into the air. I'm going to sketch a little picture on here, and I'm staying too long on this one. This one isn't the one I really want to do, but what this picture says is here at 0-0, whoever's kicking the ball, and I didn't get to see the end of the game, but I understand either Alabama lost or Crimson lost, and it was by a field goal. Anybody watch the big football game? All right. By a field goal or something, like that. All right. Nonetheless, when you kick the ball, that is one of the most famous pictures they will do with the quadratic, with a parabola. In order to do that, in order to make the picture do this, he threw the ball, he kicked the ball, all the same scenarios so that they can have one of these. That negative sign is really important. It's the negative sign that makes it go upside down. And you need it to go upside down because there are very few scenarios in life where you throw something down and it swings back up. I mean, you could be pushing someone on a swing. They might do that as a scenario. The father was pushing his daughter on the swing, and it was modeled by this equation here. At what point was she at the minima? That's math talk for, okay, when was she at the lowest point? And so what I'm trying to say to you is they're going to try to do that. So step 1, initial amount is always that guy there. Will there be negative numbers? No, because usually they'll talk about time or money. Can I have negative $10? No, you can't have negative $10. Can you do it negative 2 minutes ago? No, you can't do it negative 2 minutes ago. So, when you get the domain of a real world problem, 2 things, even if you don't know how to do it. 1, it's going to be 0, 1, 2, 3, 4. Second, when they say, what is the appropriate domain? Or are there some restrictions on the domain? You will say, yes, you cannot use negative numbers. Okay, let's see if we can get through these other 5 pages and or other 5 problems, and then on Tuesday, a little review, then we'll put it in your hand. For anyone who's nervous about taking assessments and tests, in my class the rule is this: we all pass if we keep trying. In other words, you take it the first time I didn't pass it, you see the second time I didn't pass it, third time pass it. All right, let's do some stuff. Boom, let's do it. So eventually, if you keep trying on it, it'll go through. The only way you don't pass is if you stop trying on them. It's not the way we should do class, giving you your test back. You saw it already. But it is the way we're going to do it. So let's see if we can do this. And I didn't pass out the test today, which I want to. We started on that one. I know he's going to be important. So we may come back to he's 27. Where's 25? Where are you, 25? All right, let's back up to standard 1. Where are you? Okay. Ooh, this guy. I don't think we've done him. I'm going to back up one more, and I'm going to say the thing fast, and I'm going to have you attempt to do 25. I know we've never done 23. I'm going to say 23 fast. I'm going to say 23 fast, which means you don't have to do 23, but it's kind of like, okay, remind me again about that domain range thing? Here it comes. Hey, Thomas, if you're doing 23, how would you do it? I need to get the domain, and all I need to do that is to be able to draw with a highlighter back table. You guys have a highlighter? No, table 1, they didn't have none. Now they have 2. Table there. I'm going to draw the wall from the left to the right. Now, to make it work out just right, I'm going to slide you down here, slide you down here. Got my domain already. For anyone who's like, math is hard, domain and range, I don't know, we can draw a line. Someone is going to help me out here. If you want to just throw it out there. Someone, what's the left side of the domain? Where does that go to? Alright, I got it by myself. On the right hand side, I don't know how big your pictures are. You can look on the board. What would the right hand side of my domain be? Yeah, I wish I didn't do 4 and 4. That way some students think, oh, you mean you just write the same numbers? This is kind of the last time. And again, if you want to zone it because you know this so well, that's fine. Here comes my domain. What am I putting on the outside of these? Brackets or parentheses? Oh, yeah, trick problem. Yeah. So that 4 and 4 is wrong. Can you believe that? Keep it though, because the way you get those domains, it really would be 4 and 4. I just forgot. Because this problem has arrows, what should the real numbers be on there? I hear people saying it. What I'll do for those who don't know, this arrow says I'm going back to negative infinity. This guy says I'm going to positive infinity. So technically, if I was writing the infinity version, sorry about that, people who weren't here before, you think that domain thing was it. I'll put the negative 4 and 4, and I'll just cross it out. It's actually going to be negative infinity, positive infinity, but I'm going to do what some other people said. Infinity is the only thing that gets a curve guy. I heard all real numbers. That phrase actually, sometimes I'm like, no, you don't need to know that. No, this one, math people like. They will write that often. The domain is all real numbers. The range is all real numbers. Just every number that you could put in goes there. But this guy here, this symbol here, if you know the double R, I've already seen 1 or 2 people start writing it. This means all real numbers as well. Math people like to reduce things down to a single letter because they have a lot to write. Range. If I'm doing the range on this one, of course, I'm starting on the bottom floor. I'm going fast. From the bottom to the top is the range. I'll start on the bottom. What's this bottom number? Can anyone see it? Is it a negative 3? It goes up to what? Infinity. Those arrows. You see those arrows? Say like there technically isn't a top 4. Why did I do the box thing? Because there's some students I've had in the past where they just don't. It doesn't click. But anyone can see bottom to top, side to side. When are you using infinity in real life? Never. Except in the car, and with the car thing, they decided to do that little guy there. So it's almost like I guess that little line is going down forever and ever. But now look at it. It looks like a Pac-Man. But really, they should change the name of their car. All right, here we go. Numbers get the square guy. Infinity gets that guy. By the way, if you're looking at this now like old hat, like yeah, whatever. Yeah, I know that. That's so sweet because 1, some of you didn't know it, and now you do. 2, standard 1 is guaranteed for you. Like it's a guaranteed unit now. You're about to get out of high school. X-intercepts, where are we? Now this problem, I didn't assign you guys because they didn't really put the x-intercept right on the corner. And now some students are going to have to try and guess. But I'm gonna let it be the corner unless you want to do the decimal. What did you say? Yeah, it can go negative point, 1, 2, 3. I would go 3.2, 3.4, 3.5. Any point, if a student chose to do it, I would take it from them. But me, I'm gonna mess around with it. I'm gonna just put a dot at the x-intercept. It's a big dot, whatever. So that'll work. On the other side, again, if you chose to do it on the now that's illegal. 1, 2, 3, 1, 2, 3. With a parabola, they're symmetrical, like I am. If one of you guys in here turns out to be a serial killer, an axe murderer, and you were going to murder me, which I don't want you to, which is why I'm going to treat you with respect, and even if I don't, it's only a semester, I didn't mean it. All right. And you want to hatchet me, you would hatchet me right down the middle, so that it would be symmetrical. then we'd both be like on the internet. We'll be famous. You'd be famous for killing me. I'd be famous for dying symmetrically. But the deal is this: a parabola is like me. Once you slice a parabola, it has to be the same amount on both sides. So if someone were to say, oh, that over here the x-intercept, this guy was like a it's like a 3 point. I made it really big, but it was almost like a negative 3.4. But then this guy over here happened to be a straight 3. You know something's up, something's not right. Maybe the picture's broken. I'll probably still give you credit. Once you're like, look at the picture. I'm like, yeah, I guess you're alright. But in your real life, because you'll need this in real life next time you go to the somewhere. Alright, you'll need it somewhere. No, you won't need it. Alright, next time you go to the parabola store and they ask you about it, you'll need it. So here we go. I'm actually going to put a negative 3 on this guy. X-intercept, where does it hit the line? Why am I doing this? Is this 25? Is this page 25? 23. I keep wanting to do those, and I keep doing other pages. And I'm the guy who wrote that. I'm in charge of me. So I'm very sure. All right, here we go. Let me keep. All right, y-intercepts. The y-intercept oftentimes will wind up being the same thing as the word minima. What is the minima on this one, someone? Yeah. I know you want to go with that negative 3, 0, don't you? But you got to do that, we got to do the other way. You got to do the other way. The x is 0, like, oh, here's x is 0, x is, 1 and negative 1. 1, negative 1. Then the y's are the second thing, so x and y. On the y line, boom, there it is. You only get to be one or the other. Either your minima or your maxima. The reason I want to do this one is I'm about to have you do 25. The only thing with 25, be careful. Half the picture is going to be gone, and that's going to try to fool some people. So do this for me. Attempt to do 25, see what happens to you. Pretend you were taking a test. This way you know, like, okay, I really know how to do it, or, oh, shit, I have no idea. If you get super stuck and you don't want your amygdala to make you feel bad, I'm okay with you checking with someone next to you. But if you could try to... Alright, Domain, I know it starts on this side, and then it goes over on that side. Anything back tip on Domain? Yeah. On this side, they'll put a parenthesis or a little square thing. Yeah, square. Numbers always get the square, and in math, you're not supposed to say always because there's some occasion where it doesn't. But by the time you get to that, whoever that teacher is will say, well, actually, it could be a parenthesis F. And you're like, what? The fool didn't even tell us that. Yeah. That's fine. I'd rather that, because you already know on this side, of course, we know it's parentheses. It starts at 0. 1, 2, 3. Technically 3. If there was no arrow, it would be just a 3, but there's an arrow forever and ever. Hey, range. Where are you, range? What you got, range? Oh, all right. Take your time. Kind of decide at your table who might say it, or look around like, all right. Range, you want to give anything? Bottom floor, which is also 0, and then it's right there. What you got, range? Yeah. See what I'm saying? It feels weird, like, really? They can be the same thing? How are they going to be the same thing? Something's not right about that, but it's true. The bottom floor here starts there, and then it goes up. Okay. X-intercept, what you got? This table here, I think. X-intercept, where does it touch the X line? But we need something else with that. Or say the whole thing has it as an ordered pair? Yeah. Now, unlike the domain and range, the intercepts are just regular ordered pairs. You know, there's an X and a Y, you know, so they get parentheses. So I'm like, what? You just said it's a square. For domain and range, yeah, but not for that. Let's see if we can get through this one now that we're near the end. Y-intercept, what you guys got? Yeah, why would they do that? Some students who aren't sure about math, they're like, what? It's always 0, 0? Okay, domain. If I get this one, just write the same thing. No, it just so happens that where it hits the Y line happens to be right here when Y happens to be 0. And it hit the X line right here where X also happened to be 0. So I kind of don't like this one, but whatever. Hey, minimum, maximum, what you got? Is it min or max? Yeah, it's the lowest point. When we start down low, it's the minimum. And what are the coordinates of that minimum? Yeah, this is a terrible problem. And I didn't make it up. I didn't make it up. I took it from another teacher. Um, Last thing, it didn't say the shape, but they will ask you for the shape. Anybody know what the shape of this thing is? Yeah, it's half a parabola. Really? You guys would make up a shape that isn't really a name of a shape, but fine. At least you have a teacher who knows it's coming on the test. And so he's going to put it here so that when you study, oh, sweet. When you study, at least you have access to. All right, take a look at it, see if there's anything you want to ask. Where'd you get this number? Where'd you get that number? What I want you to do is write real world, because it's a real world situation there. Then I want you to draw a table. Oh, you already have a table. Never mind. But what I was going to say is real world. How do you know it's real world? The minute they start describing something for real, I'm going to have you put in that table. 1, 2, 3. Now, I know we went back. We just kind of figured out what the partners were to that. Once you answer, don't answer again. But what's the partner to 0? 15 to 1. 25 after you answer, don't answer again. 20 to 2. Someone different. 3. 45. Did we do 4 now?
Yes.
And 4 was the partner. Now, for those who may be here for the first day or you missed that day, that comes from the situation here. Initially, when you start, your initial amount. Oh, please write that. That'd be so cool if every time you heard y-intercept, you would think the phrase, the initial amount, how much I started out with. I came into the class with my y-intercept of my brain, what it is I knew. Everything after that, it added on from the teacher or the person at the table. Y-intercept. What's the initial amount? You'd be a math student better than most of the students in this center. So here's the deal. The initial amount is the 15 bucks. Before you stay for a whole month and have to give them another 10 bucks, the initial amount is that y-intercept. Sometimes they'll ask, well, what does a y-intercept mean in the context of this problem? Your answer will be, well, that's the initial amount. That's what they started with. All right, so this one here, let's see, we scaled it as what, 5, 10, 15, 20? That's okay, you're not going to answer me. I like being by myself. All right, here you go. 25, 30, 35, 40, 45, 50. All right, 0, 15. That's there. 125. 35. Oh, do me a favor. Start putting in the domain and range if you can. You can put in your little lines, little walls on either side. There are some parts of this one, again, that are a little bit tricky. We didn't answer it all. Or did we? No, I don't think we did. Okay. So put in your picture, the name of the shape. I'll put 3, 1, 2. You get the 45, and that'll be that. I hope some of you noticed the effort that I'm making. I'm slightly excited. No, it's true with math. I'm not that excited about it. But I've been in math class where the teacher's like, oh, you serious? But then again, with a little energy, like, okay, well, the math is there, but I can feel the dude trying to make it happen. And that's what I'd like to be for you. A math teacher, when you leave the class, like, yeah, I sort of like math, but he's all right. He didn't make that penny turn into that big coin, and that blew my mind. I don't know how that happened. All right, one day I may tell you. It's called the Bobo switch, after some dude named Bobo who was like a famous magician or whatever. I bought a book, reading through it like a big nerd, whatever. But I find that for little kids, magic is amazing. It makes their life feel good. Like if I were to levitate right now, like back row, if I was to like levitate, yeah, you see me, yeah, just did it. All right, again. All right, front row, don't look down. So here's the deal. Let's get the domain, the range, and we did that. I did go to Vegas and see. Pause for like 30 seconds. If I could help the domain range people, recording, take 2. Now, don't worry, I found out a long time ago that very few people watch my videos. Yes, I heard. I mean, obviously, if you're here, you could watch it again, but mainly it's for the people who weren't here, and those kind of people, they don't watch videos. So I recognize I'm doing it. It could help somebody, but I recognize not watch that much. I haven't really watched that many of them myself, and I'm in it. I'm like the star of the video. Oh, that's fine. Here it goes. So again, I'm circling you because you're important. Where are you? Range. X-intercept. you be careful. Y-intercept, you should be okay. Max min, you should be okay too. Let's get some answers if we're ready. Find up somebody at your table. Hopefully somebody knows. I don't want to be sitting at Brian's table so you can just give out the answers. The only bad part though is if you sit at your table, sometimes you don't get to answer the questions because you're always kind of letting him do it because you think one thing or the other. Get ready. Let me pause it. Here we go. Domain. Domain, what you think? It is. It starts at this wall here, that's 0, and it slides that way. Let me say something to someone who you're a little bit iffy on the domain, when to put infinity and when not. I would almost want you to put the 0 and the 1, 2, 3, 4. I'd almost want you to put that if you weren't sure, like instead of leaving it blank. Because what that tells me is you recognize domain is from the left side of the picture all the way to the right side of the picture. And then when it's time for you to fix your test, I'll say something so like, hey, good work. It is true. It does go from the left to the right. So yeah, if there was no arrow there, you'd be right. It'd be a 4. But because it's an arrow, you always have to use a certain symbol when there's an arrow. All right, you got it? All right. Go back and kind of fix that part of your test. Oh, okay, I get it. Or redo that particular problem. So I just want you to feel like when you miss something, at least as it relates to assessments in here, there's the ability to fix it after you've been what they call remediated. Hey, Range, what you got? All right. I like those 2 numbers. The order, I'd like it to be different, though. Yeah. Why does he want the order different than that? Well, the range, you always start at the bottom. Oops. Can undo? Can undo? I can, but how can I get rid of you? Too much. All right. And the erasers are like, wait, up. Oh, it's like a baby eraser. Look at that baby. Look at that baby. All right, never mind. Here we go. So we got that. Take a look at it. So again, yeah, we start at the bottom floor. And then you go up to the top floor. Always carpet to the ceiling, never ceiling to the carpet. All right. Hey x-intercept. You all x-intercept? Yeah, what you all got? X-intercept. I see what you're saying. If this thing were to back up this way, but of course it's a real world problem, so you don't get to use those. Anybody want to throw out something out there? Yeah. I want to put. Yeah, I'll put none. NA. No intercept. Let's see what this problem is trying to say. What does it mean to say there's no x-intercept? Yeah, it's a straight line. Somehow it has to be negative. What are the x's? X's are negative months. That's what the x's are. Yeah, I see now. You can't have any negative months. That's what it says the x's are. So x, y. X's, you guys are months. And the y's, you guys are money. All right, y-intercepts, what you think? Right, Fable? Yeah, you guys wise?
0, 15.
Yeah, 0, 15. They got lucky. Or not lucky in that sense, lucky in like, oh, you got one that's kind of straightforward and not a tricky one. Yeah, 0, 15. Somebody had minimum, maxima? Or anybody can say it. What's the min?
Minimum.
Oh, thank you. What's the, yeah, it is a minimum because it's the low end. And what is that minimum? I wonder if they're always going to do that. If they're always going to make it the same. I wonder what's the situation where they won't make it the same. Do you know what that shape is? In the box? Yeah, so this one they're just going regular. It is a line. And not only will they say line, I would take line, but if you also put linear, then that's kind of more like mathy. Like if you want to like impress a math teacher, like oh, that is good. I wonder who their math teacher is. All right, so linear you can put it, but if you put line, that's fine. Pause, take a look at it, see if how it feels. And it's in the real world too. If you go to the gym, you'll need this. You'll need to know how much you. I know technically they're supposed to be able to help you. Like, okay, 8 months down the road, how much money will I have given them? You just punch it into your calculator, not you have it, and table down 8. I'm quitting the gym now. All right, so we got that. Why would we do that? if by chance you didn't pass standard 1 with at least a 2 or a 3, or with at least a 2, I would say, okay, well, go back and take a look at some of the problems in standard 1. Now, you know we've been jumping around, so you might not know exactly where to go. So this kind of does that. Standard 2, yeah, we put 1 problem. There might be more in that cluster, and the same thing in standard 3. So do that for a few seconds. That way, for those of you who are like, oh, shoot, class goes too fast. He's all talking back and doing it. Now, I'm not going to say I don't get it in front of everybody. When you go home and kind of watch the videos, you know what type you're looking at. Or when you take it to Tim, Tim the tutor, you know what type you're looking at. Take 2. The first thing I want you to write, because it's a cat situation, is real world. And because it says real world, you're going to start your table in exactly the same way we did it on the other one. So I'll do what you're doing. Check the clock, check this one, still need to get to 42. This one's going to take a little bit. This section is one of the sections where enough students get it right because it's true-false questions. So what am I writing? It's real world, green. All right. Does anyone know how I know it's a real-world problem? Yeah, it's the word problem is like kind of realish. As opposed to just boom, here's the problem. Tell me stuff about it. Oh, 2 problems that are going to be compared to each other. Yeah, I know. Because I'm actually putting my own table over here. Let's see, table. Let's see, 0, 1, 2, 3, 4. Hey, what if I didn't go up to 4? Would I be in trouble? Did I get it wrong? No, but just by the time you get to 4, the situation, you'll know the pattern or whatever's going on there. All right, let's see. Let's figure out 0. 0. This line is going to tell me what? Anybody remember what that first line is going to tell me? The initial amount. Like, what is she? How many did she start off with? Initial amount. Write that down. In the world of math, you don't have to know it all, but if you know a little bit of it really good, and that thing comes up more than once, you'll seem like you're like a math, like, damn, that dude's a math whiz. He knows the initial amount all the time. We're on the other side of the kitchen door. They made the kitchen door out of lead, so anytime it closes, it shakes this wall, so it's not an earthquake. But if it was, you stop, drop, and hold. I would apparently die, because there's nothing for me to stop, drop, and hold with. I mean, I'd get under there, like under the pole. And I'm not saying I'd push you out if I had to. That's 5. I'm not saying that. But, you know, all right, here goes. Here's the deal. How many cats initially? I heard somebody say it was a 2. Then how many she get each year? Let's see. Karen loves cats. She has 2 cats already. And plans on, rescuing. Oh, very good. By the time she's my age, 45, she'll have like quite a few cats. And you can be her friend. All right, so here's the deal. She adds 1, so she has 3 in by the end of, is it a month or a year? At the end of the first year, she has 3. How many by the end of the second year?
4.
Thank you. Someone else? End of the third year?
5.
And someone who hasn't answered? The 4th year. All right, fine. All right. Again, normally by the time you get to the third 1, 2, 3, 4 of those, you have enough. So here's what I want you to do. Step 1, situation. Always go table. If we had to graph it, which we're about to, we'll go graph second. Very few people can go from situation to graph. I don't know who can do that. If you can, I'm impressed by you. You're pretty smart. All right, so here's the deal. 2 things. I'm going to do that on purpose. 1, just know that this situation is a function, and it has a name, c of x. On the other page, you're going to refer to that name. Over here, I want you to circle this guy here. H of x. H just tells you the name of the function. X tells you, okay, the numbers, the domains, the numbers that we're going to put in. But do this for me. They've already kind of graphed this guy. If we put the arrows on that parabola, usually the parabola will always have the arrows unless specifically they put big dots on them. The next thing I want you to do is to graph the table of the cat lady. Karen, sorry. She's not a cat lady. Just a name. Call people by the names. All right, so Karen, graph her thing, 0, 2. I'm going to put mine in red, yeah, so it'll be obvious. 0, 2, 1, 3. Hey, do you all know there are some students who have trouble graphing, like putting in these dots? It's like a mystery to them. They're like, how do you do it? Maybe they put it, but someone might think, wait a minute, that's how you switch it. You put the Y on the X line and so on. But I've seen it before and I feel bad for them. 2, 1, 2, 3, 4. because clearly it's not super hard. 3, 5, 3, 5. Can you see how come you don't need all of them? Eventually you're going to see the dots, and when you connect the dots, you're going to draw a line. And that's the point of the line thing, is to say, and the arrow as well, we don't have to connect all of the dots. But once we do, we know that they're going to keep going up forever and ever that way. In other words, X is the domain, goes on and on forever and ever. Math is all about shortcuts, or at least algebra is. All right, you drew your picture, but you haven't actually done the work. The work is on the back page, which I don't have. They're going to ask you to compare the h, the parabola, and they're going to have you compare his friend over here, or her, the cat. Oh yeah, let's try this, without me answering. You're going to go to the back page, and they're going to ask you a series of questions. Do I have the power to make this smaller? Maybe, maybe not. So, yeah, it should flip over and go with it. So here's the deal. Attempt it on your own. If you get 4 out of 5 true false, and you haven't even said how you know it, you win in this section. 4 out of 5, boom, you win. Which is, in math, we usually don't like true false, because again, you could be guessing like, why not just go all false? And one true, gotta be one true. In any case, you're gonna read the question, look back at your picture, which is why we did it, and see if you think it's true or false. This last line, which again, those of you who are gonna get 4 in this section, justify your answer means say how you know it. Like if you said it's false, oh, because blank, blank, blank. Let's see, function x and h of x have the same y-intercept. True or false? Once you say true or false, then you can kind of say what their intercepts are, and that might help. So maybe let's do this first one together. So let's have someone say true or false. Okay, okay, yeah, I like that. So yeah, good effort. See that? Yeah. All right. So how do you know false, person? Or anyone else? Anyone else who wants to say how he knew it's false? Yeah. So you could say that, not the same on the graph. The function h of x, c of x have the same y-intercept. I do agree. It is false. The way I would justify it, I would put, let's see, c of x is in y-intercept. The green guy is 0, 2. So I put c of x 0, 2. They're not the same on the graph. I would almost accept that because that's real. I recognize that's where you saw it. What is h of x is y-intercept? Someone knows it. I know it's 0, something. The h of x? I appreciate that. Thank you. So that's what the justify is. But let's just imagine you know the answer, but you just don't know how you don't know how to say that you know it. You can still pass standard 3, which is why Unit 1's test tries to be the easiest of many of them. All right, go ahead and mark the others. And instead of say try and do it alone, but if you feel like, I'm not sure about this, would you put on that one? I'm kind of okay with that at this point, but I want you to do that. We're near the end now, near the end of 40. We still got to do 42. It's going to take a little while, but I tried to move as fast as I could. Let's do it. Hey, both functions are linear. True or false? Oh, sorry. It's not your table. My bad. Just talking to this table here. False. How do you say y, though? Oh, yeah. H of x is parabola. Parabola. All right. Hey, back table. I'm coming to you while other people are writing in the justification. And again, if you're not good at the justification, don't stress that you can still pass this section. This is just one of the few sections that if you do really good, you get a 4 out of 4 instead of a 3, which is good. Instead of a 2, that's good. Instead of a 1, good effort. All right, here we go. Back table. The domain of both functions are all real numbers. True or false? True is a good answer. False is a better answer. So the true is close. All right. Hey, how do we know the false thing? Right. What's your real world? You don't get to be all real numbers because all real numbers mean you include positives and negatives. If CX did just give you a bunch of numbers, then you could do that. So CX, real world problem. You could put it that way, or you could put can't have negative cats. Is it negative cats or negative months? Each X is the number of years, the number of cats. Yeah, so the domain happens to be the number of years, so you can get those cats. Let's see if we can try and get in that real world. Or, I'll put the or. Can't have negative years. Years. Alright, in the course of me trying to teach stuff, again, if you don't know it, or it wasn't clear, you can always see the tutor, of course, for YouTube stuff. You can Khan Academy it. You can, what's the other thing famous? Khan Academy, YouTube, Google, just type in the topic. Hey, maximum, minimum, where are you? Oh, right here, what do you got? H of X has a max, and C of X has a min. True or false?
True.
Alright, let's check it out. Here, true there. Who has what? Let's see. H of X has a max. Oh, yeah. It has the highest point. And then the C of X has a minimum, has a lowest point. So that one is true. How would I justify that? Part of me wants to write C graph, but can you write C graph on all of them? So you can't put that. Let's put the min and the max. H of X. What was H of X's actual coordinates for its max? Was it 0, 3? And what was the C of X's for its min? This is why they would give a 4 for this. 4 means exceeds mastery. Again, you only need to be near mastery. That's a 2. So that's why they don't just give out 4s. So if anyone's looking at it like, I'm not going to remember all that, you don't have to. I just want 2s and 3s initially, get us past. Everybody get their first unit, boom, and like, oh, this is cool. You feel you get a good impression of your math class. Eventually it'll get harder, but for now, let's keep it this way. Both functions have exactly one intercept right here, front table, true or false? That could be awkward. That's okay. Alright, say the answer again, please. True or false? Okay, I heard like a mumble. I'm going with a false. False. So that's false. Alright, I'm going false. Both functions have. Oh yeah. Exactly one. How do you spell it? We say that both have exactly one. How do you mean? Let me back. So it says both of oh dang, I didn't think of it that way. I was thinking more from the parabola standpoint. Yeah, that's good. So we said it's false that both of these have exactly one x-intercept. There are two reasons you can give. X doesn't have an x-intercept, or C of X doesn't have an x-intercept, or H of X has two x-intercepts. So you can go either way. An intercept is just where the graph intercept where the graph intersects the line. Right here at Sierra and Slover, that's like I said, an intercept. If you saw a big map, you say boom, that's where things intersect. So we call that an intercept. With that said, let's see if we can get that one. I'm gonna let you breathe for just a minute or so, and then 42, and we win the game. 42. I could put C of X no x int, or H of X 2 x ints. The other thing I want someone to notice now, notice how we can talk about the two different functions, the C of X or the H of X, so we can distinguish between the two. That's why, like a video we saw a long time ago, both of those equations could be written with y equals. In other words, it's not there. This one could be y equals. This one could be written, when you put in the calculator, y equals. But if you were talking about it over here, so yeah, y equals has no intercepts, and of course the other y, it has two x-intercepts. You're like, well, which one are you talking about? Why don't you just give them like different letters? That way you can say C or H. And so that's the reason they do that. All right, pause your brain for one moment here. Let's see if do me a favor, read the problem, and there's a phrase I want you to write down somewhere because of what you've read. Read the problem, see what they're talking about. Let me go turn. Hey, can someone say out loud after you read that whole thing what the phrase I wanted you to write? Real world. Someone different, can you tell me what the numbers are I'm going to put in the table? I heard something. I'm just putting 0. That's cool. And, oh, but don't give me the other side of the table yet. Don't give me the other side yet. Just the domain. Now this problem is going to end differently because you would think like, well, dang, math people, it's the same problem again. We get it. Thank you. But they're going to tweak it with this phrase, underline appropriate domain. This appropriate domain will also be connected to this thing called, I wish I could write it somewhere, restriction on the domain. Are there any restrictions on the domain? That restriction on the domain, we're going to say at the very end. Let's see what we can do here on this thing here. Hey, a cell phone company charges 10 cents, even though I wrote the dollar symbol, for each text message sent or received. Your parents pay your bill, but have capped it off at 30. 30 is going to be important. I even heard someone say it when I mentioned the restriction on the domain. Let's see here. A month for your text charges. If there's a function, go ahead and mark that. They're kind enough to give it to you. The minute they give you a function, and on Tuesday you'll have calculators. I don't know, you'll be sharing one, and you have to go back and forth. You'll punch that in to get your table. It's a good thing that they're doing this now. A long time ago, you have to put in 1 in the place of x by hand, 2, 3, but not now because the graph calculator is so important. Put that guy in, and then finish off this side of the table. So let's see. If y is a function that models this cost, oh, please double underline models. Models is a new math way of saying, we're near the end, new math way of saying, if there's a situation that I can write as an equation, that's called modeling. Hey, would you please model the equation? Would you please model the situation? That's math talk for it. Hey, could you write me an equation so that if I need to find out part of the answer, I can just plug it into the equation. All right, here it comes. What's the partner to the 0? Thank you. Someone different, the part to the 1? Is it 0.10? Part to the 2? And you should know that this side is the money and this side is the number of months. You put in rather the number of texts. 0.20. Oh, I see the pattern. 0.30. 0.40. We'll pause there because again, the question we're really asking is, what is the appropriate domain of the function? What are all the x's that I could use for the situation for it to make sense? So each one of these is a text, and this is how much money I've spent so far. Let me ask this question. I'm going to put a little mark here. We're near the end. How much money do I have to spend in a month before I have to stop making texts so my mom doesn't kill me? You know, I only got 30 bucks. So one restriction on the domain is the $30. Once I reach, oops, let's write it regular. Once I reach 30, I know I'm maxed out. Those are all the x's, all the amounts. I can start with 0. I don't have to make any text. That way I don't use up any of my money. I can maybe make 2 texts that uses up 20 cents of my money. The question of what is the appropriate domain is really, we know you're starting off at 0, but how high can these x's go before you run out of money? 30, it would seem to be the answer, but do this. Scroll down to 30 on the x side and see how much money you've used so far. I thought 32. 30 is the amount of money, the range, but if you go down to 30, what's the partner with the 30? How much? Is it point something? Just a 3. So that is when x is a 30, y is a just a 3, you say? That 3 represents just $3, but I get to spend $30. How many texts can I make if I hit 30? Now, it's true, if you just hold that gray button, that arrow down button, it's going to take you down to something. Say it again. Well, but on this side, how many texts? Oh, I can make 10 texts, I can make 30 texts, I can make 40 texts. How many texts can I make? And this is why this problem here is in here, to make it a little bit harder than what you've been doing. Up to this point, you're just like, oh, 0 to infinity. Come on, like, do you know what you're getting when you get this domain? Anybody get it by just holding that button? Say again. It turns out it was 300. You have to hold that button all the way to 300. At 300, the partner will be that $30. Now, someone will be saying in here, like, do I have to hold it to 300 to get it? No, you can punch in numbers. Like, if you want to, you could put in a number in the place of the X, but since you're using your table feature, just hold. The domain here, the appropriate domain is from 0 to 300. You get to make 300 texts in a month at 10 cents a piece without going over. So the appropriate domain is 0 to 300. Are there any restrictions on the domain? Yes. I'm right under. No negatives, no negative numbers. And $30 cap. I say $30 cap. I don't know how to write that. $30, only $30 cap. This is the problem that most students on this first assessment have tended to miss in the past. So if you get section 1, where you get all your domain names and all that, oh cool. That last section, true, false, cool. This one is the one that becomes pretty tricky. The good news is this one mirrors pretty close to what you might see. And then we put domain here, so the appropriate domain is from 0 to that. Restrictions, no negatives, and at the cap of $30. You don't have any more money, so you can't make any more calls.